Hello students, welcome to Sir's classes. If you have any queries about the following video, please WhatsApp us at my +91 9836793076 or email us at sortofsirclasses@gmail.com. You can also visit our website www.sortofsirclasses.com. Today we are solving IIT JAM Statistics 2017 question paper, and the problem in hand is, let AN be a sequence defined as follows. A1 equal to 1 and AN plus 1 is defined recursively, which is equal to 7AN plus 11 by 21. Now the options are basically the monotonicity of AN, if it's an increasing sequence or it's a decreasing sequence, and what is the limit of AN. So we know that A1 is equal to 1, AN plus 1 equal to 7AN plus 11 by 21. Now what is AN plus 1 minus AN? This is equal to 7AN plus 11 minus 21AN by 21, which is equal to minus 14AN plus 11 by 21. So we have just written AN plus 1. Now suppose limit as n goes to infinity AN is equal to L. From this we get limit n goes to infinity AN plus 1, which is L, minus limit n goes to infinity AN, which is also L, equal to minus 14 times limit n goes to infinity AN, which is L, plus 11 by 21, which implies 21 equal to minus 14L plus 11, which implies L equal to, I beg your pardon, this is 0 equal to minus 14L plus 11, because L minus L is 0 and 21 gets multiplied by 0. So L equal to 11 by 14. Now we will apply a trick which is given in the problem. So since you just have 4 options in this problem and all the 4 options has either AN is an increasing sequence or AN is a decreasing sequence, we can as well just check A2, which is equal to 7 into 1 plus 11 by 21. This is equal to 18 by 21, which is less than A1. Therefore AN is a decreasing sequence. This is very easy to deduce. It is also easy to deduce from the fact that AN plus 1 minus AN is equal to minus 14AN plus 11. So AN plus 1 minus AN always has to be positive. We can just check A2 minus A1, which will be greater than 0. So since it's a decreasing sequence, it is monotone, it is bounded by A1, monotone, bounded by A1. It is convergent by Bolzano-Weierstrass. By Bolzano-Weierstrass theorem, it is convergent, and the limit is 11 by 14. So D is our correct answer. Let us move on to the next question. The next question says, let f from 0 to 1 close to R be a function which is defined as ft equal to t cube times 1 plus 1 by 5 cos log e to the power t to the power 4, a very complicated expression. If t belongs to open 0 closed 1, at 0 f takes the value 0 and Capital F from close 0, 1 to R is defined as the integral of 0 to x ft dt. We have to find f double prime of 0. Now, by an application of the fundamental theorem of calculus, we get fx is equal to f prime x, because f of 0 is 0, and fundamental theorem of calculus says that f prime of x is equal to fx small f x minus small f 0, and small f 0 is equal to 0. So capital F prime of x is equal to small fx, which also gives us f prime of x is equal to f double prime x. Now, what is f prime of 0? F prime of 0 by first principle is limit h goes to 0 f of h minus f of 0 by h. F of 0 is 0, we might just ignore it. Limit h goes to 0, and f of h is equal to h square h cube 1 plus 1 by 5 cos log h to the 4 by h, which is just equal to limit h goes to 0 h square 1 plus 1 by 5 cos log h to the power 4. Now, as h goes to 0, h to the 4 goes to 0, which implies log h to the 4 log h to the power 4 goes to minus infinity, and we know that cos mod of cos log h to the power 4, this entire thing is less than equal to 1, and therefore 1 plus 1 by 5 cos log h to the power 4, the mod of this entire thing is less than equal to 1 plus 1 by 5. Now, since this is a bounded function and we have an extra h square which goes to 0, this dominates this entire function and the limit is equal to 0. Therefore, f prime 0 is equal to 0. Therefore, f double prime, capital F double prime of 0 is equal to 0. Now, let us move on to the next problem. This problem says, consider the function f(x, y) equal to x cube minus y cube minus 3x square plus 3y square plus 7. Then the local minimum m and the local maximum capital M of f are given by the following. So, if you are given a function in two variables of which you have to find local maxima and local minima, you always have to find the Hessian matrix, which is dou x square, dou x dou y dou x, and dou y square. Firstly, what is dou f? Dou x. This is equal to 3x square, y cube gets 0 because we are differentiating with respect to x. From 3x square we get minus 6x, and the rest of it becomes 0. Dou f dou y is equal to minus 3y square from the y cube term and plus 6y from the 3y square term. Now dou f dou square f dou x square, the second derivative with respect to x, is equal to 6x minus 6 dou square f dou x dou y is equal to 0, which is equal to dou square f dou y dou x, and dou square f dou y square is equal to minus 6y plus 6 by differentiating dou f dou y with respect to y. From this we have Hessian matrix is equal to 6x minus 6 0 0 minus 6y plus 6. Now if dou f dou x is equal to 0, it implies dou f dou x equal to 0 implies x square minus 2x equal to 0, which implies x equal to 0 or x equal to 2. Similarly, dou f dou y equal to 0 implies y equal to 0 or y equal to 2. So 0 comma 0, 0 comma 2, 2 comma 0 and 2 comma 2 can be the possible extremum points. Note, for minima, Hessian has to be positive definite. The meaning of positive definite is all eigenvalues have to be positive strictly. Therefore 6x minus 6 is greater than 0 and minus 6y plus 6 is greater than 0, which implies x is greater than 1 and 6y is less than 6, so y is less than 1. Therefore 2 comma 0 is the only minima point. At 2 comma 0, if we evaluate f, it gives us 2 cube, which is 8, minus 0 cube, which is 0, minus 3 times 2 square, which is 3 times 4, which is 12, plus 0 plus 7, which is equal to 7 minus 12, which is minus 5, plus 8, which is equal to 3. So we get the minima is equal to 3. If we go back and look at our options, you have m equal to 3, capital M equal to 7, m equal to 3, capital M equal to 11. So we can easily cross out B and C. Let us find out the maxima now. For maxima, H has to be negative definite. Therefore 6x minus 6 has to be less than 0, which implies x is less than 1, and minus 6y plus 6 has to be less than 0, which implies y is greater than 1. Therefore 0, 2 is the only option, and f of 0, 2 is equal to 0 minus 8 minus 0 plus 12 plus 7, which gives us 19 minus 8, which is equal to 11, which is capital M. So going back to the options, capital M is 11 and small m is 3. So D is the correct answer. Thank you.